Yeah, that's a problem. That's a we're right.
Right.
I guess we have slides.
No.
No?
No,
just
there's no slides, just. And in theory, we have 1 hour of this. Like on the timetable, I believe we have, which obviously we're not going to fill. So I think it's officially time, isn't it? So hello, everyone. I think it's officially time, but seeing as we're in the metropole, we'll give people a while longer to try and find us because, yeah, like a week or two.
Especially as we are in attention. Especially as we are in attention.
Yeah. Should make sure it works. Sure. Who's got a HDMI port that works?
Mine is, but mine is so I need to moment.
Don't know what that looks like on this printer.
No.
I was hoping to happen.
Ben, why, do you have an HDMI port that we could test for a second one?
That would be great.
I do not. Well, hang on, I could go and find it on there. Or
It could be about, or it might be something to do.
Just because, well, it works.
nope. Same one.
No, it's
Oh, okay, thank you. Let's try.
No, yeah, it's us.
Good. Does it have a normal VGA input as well?
No, it's just a
Just HDMI only. Okay. Oh, I mean, I realize that it's the same behavior, but seen different brands.
Yeah.
ThinkPad. Oh, okay. We tried 3 different.
Let me try and
Yeah.
the
We
old.
tried turning it off and on again.
That's exactly what I'm doing.
That's a sound engineering practice.
The lights didn't turn off.
No, they take a little while.
Yeah.
I'll push reset.
Can I push buttons randomly to try and make it turn off?
Maybe not.
Okay. Also, no, don't touch it. No.
It's
Wow.
crazy how your shoes are reacting to the noise.
I predict failure.
Yes, so the operations area is having slight operational difficulties.
Okay, so we try and. Okay, that's.
It's still plugged in, so I'll unplug it and plug it in again in case that somehow makes it renegotiate.
Possibly, and then maybe if we.
It's got a picture on it on this side.
Right. Let's have a look at.
You can find a Mac because Macs are always there. We can try a different machine if that's suitable, which is just because that's not mine and it's all Chinese. So
Well, it's going to complicate as well. See?
So I can put
Yeah,
this
let's try
twice.
you again.
we do not understand your character set. Keep it.
Yeah, we'll close the window for us.
At least it's different behavior. Last time there were also 2 lights on. Now there are 4 lights on. I don't know what any of the lights mean.
Yeah, they mean
Okay.
the outputs.
Okay.
Let's just quickly.
It's now sorting. We have those.
Yeah, no,
okay.
oh, we unpack from there to try this one, and
So
we'll try
we
yours
have what we
again.
want to do, change the resolution?
I wanted to go into the display settings.
Let me get a Mac. Because all computers aren't Mac.
So it's quite heavily loaded, so.
Yeah, sure.
Maybe you need to change the monitor.
So we're going to get on 720 should be right. Let's try. Do you want to try 1080? Or yeah.
So which one?
Try 1080 to see. And,
May I try?
keep changes.
It works?
No,
No, but I mean, just
try it anyway.
do it. Yeah.
Okay.
It's, yeah.
What is that? May I try? Just because?
Yeah, please do.
Because giggles. Okay.
See that you're in.
Whoa!
Ah, excellent.
Okay.
Oh, hang on a sec. I don't have any other slides on my machine or anything. Displays.
I think it's better to use Mac.
Yeah, let's try Ignis's. I mean, not Ignis's 10 runs again. I also need to like close all of the hundreds of windows I have
It's
open.
for me, so just have a stick if you need. You can transfer the slides.
Close. Wow.
It's the same thing.
Keep telling people Macs are better.
What's that?
I mean, it's been working all morning.
Where are the slides? Where are the slides? Oh, do you have them on here?
Yes. There are no slides. It's just a medium.
That's a VGA.
VGA.
DVI. But that's it.
Materials. Go faster. Good thing we padded the meeting by a few minutes. Wow, there are a lot of slides here. Oh joy, and they're on PowerPoint format. What could possibly go wrong? Full screen. Do we have a clicker? Yes, clicker. Not a USB drive.
So I can take that back probably. Thanks.
Okay, displays. Let's see if I can see that to make it mirror. Show mirroring options in menu bar, arrangement, mirror. Woohoo! Technology. Why am I in the speed window? Don't save. The screen.
It's the,
I don't use Word down there.
yeah.
That one?
No, that one.
That one. As you can tell, I'm not a Microsoft user.
Okay.
Woohoo! Okay then, so that only took us 9 minutes of stuff. Good thing we're not an ops group or anything. So, hello everyone. Welcome to the ops area part of ops area and ops AWG. Here is the note well. It is the new note well. It is fairly similar to the old note well, but has other changes. So we are going to need a minutes taker and a Jabber scribe. So we are going to need a minutes taker and a Jabber scribe. So we are going, okay. It's amazing how like nobody makes eye contact when one's sitting up at the front being like, who will be willing to be a minute taker? Wes cleverly took Jabber because now I can't, force him to be minute taker. Joe Clark, I know, is working on fixing something, but I figure by now he's probably fixed it. And Rancid, I'm sure, works fine now. And so, Joe, will you be minute taker? Oh, hang on, you might have issues for later on in the meeting, won't you? Because you've got an excuse. Elliot Lear, I saw, there's Elliot. We're not actually looking for best at this point, just, I know. Anyone else? I noticed that Rudiger is suddenly drinking his thing and shaking his head. Okay, so I guess we will be having some minutes with some, oh, I see an L. Morton hiding in the back of the room, crouched down. L. Morton, sir, if we ask you nicely, would you please?
I can try to fill in the gaps.
Okay. I see how this is going to work. So we will have 2 sets of minutes then with small sets of gaps, and hopefully they don't misalign too badly. Okay, then that's how we're going to do it, it looks like. So somewhere in the room, we have some blue sheets. They are slowly circulating. Please make sure to actually sign the blue sheets. The Secretariat gets mad if we don't, and they can be kind of scary. So this is our agenda. Does anybody have any bashing of the agenda that they would like to do? Great. So first off, we've managed to figure out our that. And now let me stand up and go to the big mic. Actually, I can do this sitting. So as everyone presumably by this point knows, Benoit is stepping down. And yes, no need to burst into laughter at this point. I know you're happy about it. So yeah, Benoit is stepping down on Wednesday. And he is counting down the hours and minutes and seconds till then. But, I would like to personally thank him, very sincerely for having been an awesome AD to work with. I arrived knowing absolutely nothing, as I'm sure he'll be happy to agree with. Knowing absolutely nothing. And Benoit has been truly awesome in terms of sort of teaching me how this should all work, answering a lot of truly stupid questions, and then answering them a second and third time because I forget the answers the first few. And just, generally running the management part of ops and management for a large number of years in a very dedicated and thorough manner. And also, more importantly, sort of keeping the culture alive and showing how stuff in the ISG should be done and the right way to run things. And so seriously, thank you a huge amount for that. It really means a lot. And thank you, everyone. And we also have a small token of our appreciation. Both of us, unsurprisingly, it is alcohol. We have at the end of however many years, how could you not need large amounts of alcohol?
This is actually AD fuel, a correction. This is not an alcohol directly. It's AD fuel. So,
Well, thank you. Thank you very much.
So, as Spencer would say, make right choices. And when I see that, Carolina, 25 years old, and Octomore. I mean, these are pretty good choices. So very proud of you. So yeah, it was quite a fun ride, 6 years. You know, normally you always do a term or two, and then you know, there was this Yang stuff that I wanted to finish. So it has been fun, challenging sometimes, but I don't regret it. I learned a lot, and you know, with the question that you were asking, what I learned after 6 years is that the more I know I don't know, because there's so many things that is happening there. It's always like learning. So actually, I learned a lot from you guys, and thanks a lot. So you wanted to say, should I say a few things about the AD transition? Yeah. All right. So I want to be a little more formal here. When we prepared the discussion, this meeting with Ignace and Warren, we're thinking that maybe it would be good, you know, from time to time I do like a Yang State of the Union, and maybe in light of this AD transition, it would be good that if I would cover a couple of points there. And you know, where we are, what we've been doing, which problem we'll have in the future, or maybe we'll have, and a question which I've been receiving multiple times, which is like, is the next AD still a Yang AD? And the question is, should he be, right? So, and maybe I want to, maybe during 5 or 10 minutes, explain the situation. So, 4 years ago, we made room in the ISG for someone to focus on Yang, right? It means that I gave away a couple of working groups like Opsawg and then radius and diameter and LMAP, and because we saw this tsunami of Yang modules coming, right? And we were right. There are many Yang modules, so somehow it's a success for what you guys have been defining. And yes, there are many Yang modules, right? If I look, like we had like 6 new RFC published this week with Yang modules. We still have like 250 Yang modules coming. If we look in the Yang catalog on which we're working in Hackathon, we have, as of this morning, 3,214 Yang modules, unique ones, right? So what you guys have been defining, is used, and you know, it's a good problem to have. Now we are on track, I believe, with you know, Yang, right? So the idea was to say we're going to standardize the protocols and the encodings, and you know, if you see this Yang catalog and this logo there with all different Yang modules, the idea was to say let's try to standardize maybe the 200 Yang modules or 300, the ones that are key for everybody. Now, I still believe that we're going to have a couple of challenges, and I'm going to just throw them on the wall and see what sticks, and maybe this would be like where you could have an impact, right? So in terms of what needs to be improved, right? Because the solution is not perfect. We are an organization where we have running code and consensus, which means that by definition, consensus takes some time. And, you know, for operators, sometimes it's not fast enough, right? So in terms of big problem we might be having, or we have, right? This is like, how do we update those Yang modules? That's one big one, right? We know that, you know, by definition, with the Yang rules, we need to have the perfect module day one, because they must be upgraded in a backward compatible way. But we know also that this causes delay, right? Because they have to be perfect day one. So as we learn more about those modules, and we need to update them, right? The last case was from a different SDOs in the hackathon where, you know, they realized they made a mistake, right? So they need to be updated. So this is where, for example, we'll need to have something like semantic versioning, where we say it's a major, minor, or patch upgrade, right? And also next to what we've been doing in a hackathon, those health metrics about Yang modules, right? Because regardless of how good we believe we are, in the end, this is where it's used because it compiles, there is some maturity, it's imported, there is code, etc. So maybe we'll have to think differently about the problem there. And the next big point is maybe we want to focus on what I call the product of the RFC as opposed to the RFC. right? It's great to have an RFC number because you could have it in RFPs and the vendors would implement it, but in the end, they care about, like, in this case, those Yang modules or anything you could extract from the RFC. And it means that if we focus on those Yang modules, then the process could be changed, that we run the process directly on those modules. And from time to time, we go and produce an RFC number. The next big one I see is the examples, right? We start to have many examples in those modules, and this is a good thing. But how do we validate those? How do we make sure they're fine, right? Somehow it's done by the Yang doctors, but we should automate this. We should have, you know, if we speak about GitHub, for example, next to the Yang modules, we must have the examples, but also the way to validate the examples. And along the time, have more and more examples, which means that we'll have two different life cycles, one for an RFC number and one for all the modules and the examples and the metadata and all this. So that's quite a big one as well. And the other one is maybe where is the source of truth for all these modules, right? So people should extract this from RFCs, right? But you know, working with IANA, it could be that IANA is the source of truth. Now, sorry, if we come up with IANA, then sometimes we have, like, in one of the examples, you get an RFC, a Yang module, and a bug. Oh, surprise, right? There is something to be corrected. Now, where is this Yang module with this new correction, right? Now we're asking people to extract the Yang modules and to apply the errata. So it means that we'll have to think differently and maybe have this in IANA with the bug applied. So what does it mean? There is this time zone database, right, where we have a coordinator. So I believe at some point in time we will need to have the same thing, where some members of the community would be in charge to say, this is the Yang module, this is the latest version. And if we combine this with the health metrics I've been mentioning, it validates. And as we learn more, there are more validators, there are more features, etc. We'll have to correct things. So this is maybe another thing that will need to be done. Now, again, maybe it's a long list of problems, but these are good problems to have. We went away from the phase where we have to sell a technology to it's known, it's used, to the phase of optimization. So maybe to answer the question I've been receiving multiple times, should the next AD be a Yang AD? Maybe not, right? But we are in the optimization phase, and you will have your own set of challenges. So welcome.
Hi, Elliot here from Cisco. First, Benoit, thanks very much for your service for these many years and for your commitment to operational excellence in all different ways. It's very much appreciated by me personally, and having a level head in the room that always helps. I wish we had more of them, and I'm glad to say the ops area has generally been pretty good about that. We have 3 great level heads there. As the person who organized the TZ database coordinator, I have some thoughts on that. And I think there are some, it's an interesting idea, but I think there's some interesting differences. The problem with Yang is that there's code associated with it, and lots of it. Nobody writes a Yang module just to have a Yang module. There's actually, there's compiled code into products. And so as we think about this problem, a coordinator might be the right approach, right? The coordinator might need to be a bit of a policeman. And as it happens, I know a man with a badge sitting next to you. And the reason that I think about it in these terms is, it could be that if somebody wants to bring something forth through the IETF as a Yang model in particular, that maybe what we're really looking for is a little bit of commitment from that individual, or maybe a group of individuals saying, yeah, we're not going to step away from this once it's built. We will answer errata. We will answer, we will show operational excellence. And it could be that I'm not suggesting that we have a section in the RFC, for instance, that is how we're going to show operational excellence. But at least when they sell the idea into the IETF, they should answer that question, so that that means that they're not just going to come here, get their RFC number, and leave, but actually show some sort of commitment to maintaining this stuff. I think that's very important, and I think it's a little different from the TZ model, where you have a bunch of volunteers who come and go, and we only have 2 coordinators who honestly have been doing the job in a sort of thankless way, where they've been sued and all sorts of other things for their efforts. And now, I'm not saying we should, use the lawsuit model as the way forward, but in terms of your thinking, I would say, think about the man with a badge and how to gain that commitment for operational excellence.
Right. Thank you, Benoit, for leaving the state of Yang as it is, and for me to try to take that over. So, a few comments on the view of how the things might continue from my perspective. So, my view is that the core work on Yang language itself, the protocols, is mostly done. Not necessarily done, but mostly done. It's stable and self-sustainable. We certainly need maintenance of that. But the bigger work area is in the modeling, and modeling from the practical point of view, that we don't develop models just because it's another fashionable trend in the technology. We develop the models which address the actual operational needs and in a way how they are actually being used in the field. So it's about the operational workflow and more on the operational workflow and usability of the modeling, and less so on the protocol mechanics and other things that we are typically used to work in IETF. Also, the outreach into the industry, and especially the operational part of the industry, is an important part. IETF is mostly, from a perspective of Yang, IETF is mostly a closed-in organization. Yes, everyone dealing here understands that technology and builds on that. But if we look into the actual field, into the deployments, Yang is still not there, or at least not up to the level that it should be, given the amount of work that we are investing here in IETF. So from that perspective, the focus likely needs to shift more into modeling. Using Yang becomes more of a tool, not the end goal, but this is just a tool in the process of defining how the other technology components, which are being controlled via a family of Yang things, can be used operationally and in a practical operational way. So at least I have this as a goal for myself, and I do understand that talking is easy, but trying to do something here involves a lot of moving parts and a lot of other entities outside of IETF. So basically, we need to focus on the requirements for the users of the technology, the users of the Yang, and less so on the requirements which are coming only from other working groups and other technology domains within the IETF. So I think that work phase is complete. Yang is stable, relatively mature. Now it needs to be brought into usability.
Any questions or comments on that in particular, or shall we go into our open mic / performance art section?
Too old for this. Joe Clark, Cisco. First of all, Benoit, come on. I've known him for a while. I think you were at Cisco when I joined back in '98 already. We went through some hell with SNMP together, some hell with our own products together, and I guess some hell with Yang together. And we've, I mean, you definitely got me a lot more involved. I appreciate that. You got me a lot more connected to Yang and solving some of the problems and hopefully avoiding some of that hell for people to come. Specifically on this operational thing, one of the things, Benoit, that you kind of brought to the forefront, and I think, Ignis, to your point about operationalizing Yang, and you mentioned the product of the IETF shouldn't just be the RFC number, and Elliot said, don't just get your RFC number and go. It's about how do we move faster to help operators adapt or to help the operators consume the products that we're putting out. How do we move more into that open source model where we're producing Yang models and iterating over them to help solve the problems that the operators are actually facing and in a timely manner so that they don't have to go and look for other ways of fitting, say, a square brick into a round slot for it. So I'm hoping that we can keep some of that momentum going and that we can be better about producing products that meet operational needs at the velocity that it's required to do so.
So you know this, Joe, but for the rest of the audience, what we've been trying to do to address Igna's point is that, you know, even if I mentioned many times Yang in my talk, right, maybe too many times, in the end, we want to have end users not caring about Yang. So what we've been doing with the catalog is that you just select something. You want to manage a VLAN, for example. You select it. You found the right Yang modules, and there are plenty of ones. Then you look at the health metric there. Which one is the relevant one, based on maturity, based on validation, based on code, whatever. And there you just click, and then you just produce a Python script that will go and configure your VLAN. This is what we need to do more. And then the second thing I want to add is, you know, we did that during IETF hackathons for many meetings now. We want to move this to the next level, and we're trying to get like ISOC money to have one person assigned full-time for a year on this, right? Because if you want to have this like in production, right, really for operators to offer them a service, we need to have someone like dedicated. And I'm still hopeful that it's going to happen. So whenever we have that, then we have the full story. And we have like all the revision of Yang module. We've got all the metadata. We've got the usability. So this is my hope that we'll get that funding.
Alrighty, so I guess let's go into the open mic session for Ops area. And I believe there will be another open mic session for Ops AWG in a little bit. So going once, going twice. And this concludes the Ops area part of Ops AWG and Ops area. Thank you. Thank you. Seriously, that's it.
These are good bottles.
Oh, good.
So, you were teaching me about whiskers.
Yeah.
Did I learn something?
Oh, yeah. You run quick.
Alrighty, seeing as I seem to be the person with the working computer, I will, I guess, continue presenting for Ops AWG part, assuming the chairs would like that, and assuming I can turn off full screen mode. Let me also close my chat program. I'm impressed that nobody thought to mess with that. Yeah, would you like me to be the presenter? Sure. On the machine?
We can.
Sure. And, okay, first we have some administrivia.
Yes.
Yeah. So, and I think I first got administrivia because of you. I think I just had to mention that we were moving the So, first off, we have some final Ops area administrivia. We currently have 3 chairs for Ops AWG, and one of them is Ignis. So the plan is Ignis will be stepping down as Ops AWG chair, and he will end up becoming the responsible AD for Ops AWG instead of me. So, you know, thank you for your service as Ops AWG chair, and sucker for becoming AD.
So thanks a lot for that. And this will happen sometime during this week. And this is an interesting use case for a data tracker that once formally AD switchover happens, then we'll try to do the chair switchover, and the person switching is the same. So we'll see what goes with the data tracker. It's a test case for that. So then Opsawg will move to be I will become the responsible area director for the Opsawg. The rest, as Opsawg was continuing with our focus, they hopefully will continue doing exactly the same. And now we are moving to the Opsawg meeting. And as I'm no longer formally a chair, I will leave the stage for you.
I think you're formally a chair until the changeover happens. So you don't get to escape that easy unless you really want to.
But there appears to be too large of a concentration of chairs, of both physical chairs and chairs as roles at the same table. So, okay, I can stay here.
So begins the Ops Area Working Group session of our meeting. Does anyone still need to fill in the blue sheets? Wow. Alex does. Yes. There the slides are up. Elliot and Al, will you continue to act as minute takers? I fully understand that. Hopefully, Al, you'll fill in the gap. He escaped.
I see Mario over there, who's usually also in that 15 minutes. And he's not looking around.
I lack context in a lot of things.
Okay.
Okay. And Wes, you're still on Jabber. Okay. Oh, I guess I have the clicker. As was pointed out by Warren, the note well has changed a little bit. Please note well. In particular, it has been updated to be more in accordance with how the IETF operates. And so you can see all of the various items there. It has not changed, however, between when Warren first introduced it. Not that I know of, at least. As for who we are, we've already gone through that. I'm Joe Clark, joined by Tian Ren and Ignis, at least for the time being. We've set up all our scribes and minute takers, and we'll move right into the update section of our meeting. You want to talk about?
After last meeting, the service model explained document has been published as the RFC A309. Now we have 5 active working group documents. Firstly, the CAP Web Alternate Tunnel document has finished all the working group procedure, and now it's waiting in the RFC queue. And we also finished the first last call for the IPFix BGP community document. The major problem is about the use case and the motivation. Later, the author will report the latest revision. We really hope more input from operators can help this document. And we also send the NetEM model and the mod work to the ISG. Joe, do you have any details on that?
So the first with MUD, we're going to hear an update from Elliot on that. I believe that there's a few changes that might need to be made. Elliot will touch on them, and it might have gotten pushed back a little bit from a telechat standpoint due to some other queuing. Yeah, just scheduling. In terms of the NAT draft, it has gone through its Shepherd review by me. It has been submitted for publication as shown, but again, hasn't had a chance to be fully reviewed by the ISG, just again, due to the scheduling.
And the last one is the TACUS protocol. It's in good progress. The authors have addressed most open issues.
Alan wants to say something.
Yeah.
Sorry, this is Alan. They've addressed a number of the issues, but not all of them. They're not engaging.
Not
And
not
the
all of
text-
them. I can see almost most of them. Is
It's
is
also
that
not
correct?
engaging. And as I have noted on the list, my text is still in the document with no acknowledgement that I wrote any of it. So I don't know what's going on here. It's a serious problem.
So I agree on the engagement. I reviewed the latest, the '08, and sent email asking them, one, to summarize, and two, I had some points and I have not heard back. In terms of the accreditation, you're in the contributors, the acknowledgement section.
As reviewing the document, not writing the relevant text. And the initial cut and paste of my text was verbatim with no excuse for it. Come on, this isn't high school. People know to give acknowledgements for text that you're cutting and pasting. There's still no acknowledgement that a good section of the security considerations text was written by me. If you want updates, if you want engagement, I would be happy to take over editorship and do whatever the working group wants to get this done. But waiting months and months between between releases, dropping a new release and then running away, it's not engagement. It's not a way to get things done.
I agree, we do need more engagement. Have you heard, I know you were liaising with some of the,
Yes, for the 07 revision, I was in discussion with authors, and since then, there were no major changes to the document. So my suggestion in this case would be that, again, instead of trying to escalate this as a possible conflict within the working group, to try to liaise with authors and simply explain.
I've done tons of liaising. I've had all kinds of detailed reviews of the document, more than anyone else in the working group, more than is normal for this kind of document. And the response from the authors has typically been ignoring it. I can't liaise anymore. It's their responsibility to engage, and they have not.
So, okay, that is understood. I cannot answer for the office. I'm not aware that any of them is present in this meeting, and this document is not being presented. The only thing that I'm stating as a fact that I did liaise with them at the time frame of 07, and since then, there were no major changes on this particular topic.
So there are changes between 07 and 08. There are quite a few changes between 07 and 08. A good number of them were to address my reviews, which I do appreciate, but some parts of my reviews were not responded to and did not result in changes in the document. So, I mean, anyone can write a document and throw it over the wall occasionally. The point is to get consensus on it. And I do not see that happening. So if the authors repeatedly, for the past 3 years, do not engage and do not move towards consensus, then I have to question why this document is here, or why the working group cannot put someone else in who will move towards consensus. I mean, look, despite me doing radius, I'm not here to shut this down. I read the document and I had no idea what to implement. And 3 years later, I'm still pretty sure I have no idea what to implement. We can't publish a document like that. The security area review will punch it back, if nothing else. I don't understand.
So there are two questions that you're asking. First, why this document is in the working group? At the time when this document was adopted, there was a consensus to adopt it. It was a long time
Why
ago.
it's in the working group. What I mean is, why are the authors not engaging? Why is the working group not pushing it forward?
So I cannot answer for the authors. There were contacts with them. Yes, the process is not moving that fast as it could, but I'm not one of the authors. I cannot answer that on their behalf.
I may. Elliot here again. I sympathize with Alan's point. If the document's not moving at a reasonable pace, then it's worth the chairs getting involved to start to figure out how to get it to move. I think that's a perfectly reasonable request. But I don't think you can solve it here. I just think it's worthy to mention it, and then let's move on is my suggestion.
Yeah, I mean,
Yeah, we feel
for my
this,
summary, it's basically either publish it, drop it, or get someone else in who will publish it.
yeah, we notice this is a serious problem, and we will bring you and the authors together and discuss this, how to solve this.
We've been discussing it for 3 years.
Unless you object, I'll take personal AI to follow up and get this moving with the authors.
Yeah, let's continue with the following presentation.
Next. Oh, sorry, that's me. Elliot Lear. And all speakers, we still have the magenta tape where you must stand in order for our remote participants to be able to see you. So please try to confine yourself to the box. Yes, mud status.
Hello, it's Elliot again. All right, so this is a brief status on MUD. It's where we are and where we think we're going to go for next steps. So MUD is manufacturer usage descriptions. Basic idea is for the manufacturer to be able to communicate various aspects of a device to the local deployment, particularly the network side, but doesn't necessarily have to be limited to that, of what the device is and how it's supposed to behave. Next slide, please. So this document is past last calls several times, actually. The thing that has slowed it down is that it is normally referencing the ACL model. And the ACL model essentially took a year to go rework because it's been through 5 last calls. And so one might get a little tired of the last calls, and I hope that the NetMod working group is tired of their last calls, and they're down to little issues like whether a non-terminal node in the Yang tree should be called access lists or ACLs. So that means that some of the examples in the MUD document will probably change as they finally wrap up, but we can handle that in Auth 48 as we're moving on, as I've discussed with Warren. There's one error in the current draft, at least, which is that system info is currently listed as a URL. That's a holdover. We just got that in this working group. It should move from URL to UTF-8. The reasoning being that the applications people in the reviews basically said, you really don't want to do a lot of HTML processing, too many bugs in that, too many opportunities for vulnerabilities. So don't do that, especially on your first time around. So the other thing they said is, and stop messing around with the URL, was what they basically told me. You have to not constrain it. And so we had a fairly lengthy negotiation about that. The basic issue is that BCP 190 says you can't impose strictures on the form of the URL. On the other hand, it was written at a time when you basically had a web browser and a web server, and you don't want things in the middle monkeying with it. We don't have a web browser on one end of this discussion, on one end of this connection. We have something putting out DHCP or LLDP or being pulled out from or information being pulled out from a cert. So our model is a little different than they envisioned. In any event, we've come up with some text which is advisory, which says, look, just leave the query element alone, or we advise you to leave the query element alone because we might be standardizing that in the future. And we haven't decided. We're going to have that conversation, but we're not going to have the conversation in last call of a document. We're just going to, we're going to say, well, that's future work, and let's move on. And this is where we've left things with him. And the applications area director in particular, Adam, it seems pretty happy with that approach. And then he wants to actually have the conversation, which is really good because we should. The telechat date for that is April 19th. My one regret is that Benoit won't be able to yay or nay this, but I was hoping that things would finish so you could do that, Benoit. But hopefully it will happen soon enough. And as Warren told me, the stack of documents in front of us is quite substantial, which is why the date is what it is. All right, next slide, please. So just as a reminder, what all this is about, the thing that MUD started to tackle was that middle green one, which is how do I protect it on my network, and also the one below it, which is it doing what it should be doing? And so we've been focusing on that. And so for the other stuff, like what is this thing, we're talking about using mechanisms like EAP and 802.1AR and other things to identify the device to the deployment. And then we're looking at how to broaden all of these answers for various different forms of technology, like 802.11, like 3G, 4G, 5G, and across different markets or different segments of the markets. Next slide, please. Sorry. Oops, just a little bit back, if you would. There you go. Okay. So one of the things we didn't touch with a 10-foot pole was in the first round was how to handle sort of bandwidth expectations of a device. One of the reasons is that I still have scars personally from dealing with QoS in the early 90s, between the early 90s and late 90s, and wasn't quite ready to start with that when we had some really low-hanging fruit just on access. But now we really have this question. So you installed a device, and you don't really know how much bandwidth it's going to take out of your network, nor what it's designed to take out of your network. And maybe it's a fire, maybe it's like a little temperature sensor to detect fires. Maybe it's going to do, it's going to need like, a packet every 5 minutes, maybe a packet every minute, depending on how it's designed, and no more. And all of a sudden it starts spewing. Well, it could be that there's a fire, and it's saying, hey, there's a fire. Or it could be that it has a noisy transceiver, and so something's gone wrong with the device. But you don't know because you don't know how it's been designed. And so the question before us is, can we provide a description, or can the manufacturer provide a description of that sort of behavior, both when it's in nominal state and maybe when it's in exceptional state, and such that the deployment can have some understanding of how the device will behave in those two states from a bandwidth utilization standpoint. And so this is sort of researchy in that we're not sure that the manufacturers are actually going to be able to do this, but it's been put that we should discuss this, and so I'm raising it with you as a point for your future work. So the way that we're thinking about this is that when we talk about bandwidth utilization, it can go in two directions. Conveniently, the MUD model thinks in both to the device and from device already, and so we're thinking about extending it, extending the to device and from device containers such that you could add some sort of description about this. And the idea also is that you could use this for other purposes, like, for instance, provisioning purposes. So if you have a bunch of devices that are, say, cameras, and might all be chattering at the same time at, say, HD speeds, you could have some notion as to add up the amount of bandwidth that you might need in those environments for provisioning purposes over time. Now, what this is not talking about is how to duplicate or how to create QoS in the network. That's already been done. Not going to do it again. Have the scars. Next slide, please. Okay, so I've covered a bit of this already. One of the questions that we have, right, is if a device is sort of pinging out there saying, here's how much I'm going to use, right? Over what period of time should we do those sorts of measurements? And by the way, it's not just bandwidth, but maybe packets per second or something else. And so we're pondering what the right measurements are in order to describe these profiles. So this is sort of, again, it's a bit researchy to figure out exactly the right elements to describe utilization, but it's not that researchy because we've done this before in other contexts, whether it's in NetFlow, where we've looked at how NetFlow or how IPFix has handled flow information. We could probably learn a lot from that. All right, so next slide, please. So the other problem that we're working on, which is sort of separate from MUD, is more of an onboarding problem. And this I'm going to talk a little bit about in EMU later today in more depth. So this is sort of a little teaser for if you don't normally attend EMU, and why would you? Because this is Opsawg working, it's sort of a security thing. Question is, how do we now gotten to the point where we can describe a profile of a device, We even know how devices can connect and be have a trusted introduction, say between them and the local deployment. That's what Anna Mabruski is doing. But for Wi-Fi, we have two additional problems. Problem number one is, how does a device choose the right network to join in the first place? And problem number two is, how do they authenticate initially? So we're going to leave the how do I choose the SID problem essentially alone, because that's probably closer to an IEEE or a Wi-Fi Alliance question and not so much an IETF issue. But I just wanted to note it for completeness because we have to solve the complete problem. Next slide, please. Oh boy, this is some of the slides didn't come out quite right. Okay, so the problem though with Wi-Fi in particular with trusted introduction is that you want to join the network even if you know the network, right? And so the way that the Anna Mabruski flow works is you basically have some RESTful calls and you do a little RESTful dance with something called a registrar. But how do you do the RESTful dance if you're not yet authorized to use the network as is required in a Wi-Fi environment? Okay, that's a chicken and egg problem that we have to go sort. So we're looking at several different ways to sort that. That is to say, we'd like to use this Anima flow, and we want to also, but we don't have an IP address. Well, that's sort of EEP-ish, right? In order to do that. And there's this whole thing called TEEP, which is relatively new, which is new EEP method, which seems, roughly speaking, to be what we want, but there's not a lot of deployment there, which makes us a little nervous. So there's a new draft that Owen Friel and I and Michael Richardson wrote on this to go look at these different models, and we want to actually try and take a swing at this. All right, so next slide. Coming back to MUD, we have some open issues. As I mentioned earlier, the apps area people had some BCP 190 issues that we wanted to discuss. And why would we care about URL composition? Well, right now, if you transmit a MUD URL, if a device outputs a MUD URL, say in a certificate, that's the manufacturer asserting what the device profile is. But a device can't change that URL, say if it does a software upgrade. And so you might want some of that posture information. Well, conveniently, NEA has done a lot of work on posture information. So maybe we want to communicate some of that back to the manufacturer. So say a device is running version 2 of a particular piece of software, and version 2 has more capabilities, then perhaps what you'd like to do is communicate that to the manufacturer so it can provide a more tailored MUD URL. That's just one example of how you might want to add stuff into the URL, say at the MUD controller level. And we didn't touch that initially in this document, but we're now thinking about it, and we're thinking about what's the right way to go forward. One way is to append stuff into the URL. Another is, for instance, to create an HTTP header and stick that stuff in there and pass that to the MUD file server, which is basically an HTTP server. We didn't really want to do the latter early on, and the reason is that we thought the simpler the web server implementation, the easier it will be for manufacturers to implement. So this is one issue that we're thinking about as well. The next thing that's left over is sort of a life cycle issue. Next slide, please. And so suppose you got a device that you bought in, say, 2018, and then you pulled out of the drawer in 2050 and wanted it to work. It just happens to be an old light bulb. Now, this may sound crazy, and I've chosen the time frames to be a little bit extreme, but it could be, instead of 2050, you could say, well, we pulled it out of the box in 2025 or something like that, and you still want it to work. And if you think that's crazy, consider this example. The Formula One team, McLaren, all their control functionality for their racing car is on like Windows 95, and what they did is they bought a stack of PCs so that they'd never have to upgrade the software in the car. Well, they're running out of PCs now. Well, this is sort of the same problem, which is things do tend to, there's a lot of stuff that tends not to change, and companies do go away, and with them go their names. So I was talking to Hank about this at lunch, and he said, oh, you're just going to run your internet simulator in 2050, and you do a query for this information. And it's like, yeah, that's a way to solve it. This came up apparently at the SSAC meeting at ICANN, by the way, because they're thinking about long-lived names as well. Now, we
you know, the people keep saying, what happens? What do you do in these circumstances? And my first answer, you know, my first order answer was, you're screwed. The name's gone and that's that. But we don't really want that to be the real answer. So we actually want to put a little thought into name lifetimes and MUD URLs. So these are the things that we're thinking about working on. I think that's my last slide, if memory serves. And Hank himself is thinking about MUD URL composition and how to leverage that classifier for other uses. And he's going so far as to say, you know, over time we don't really want to use Yang for these things. We want to use something else. We left open that possibility, but exactly how we do that has to tie into the classifier itself. And so as we get more operational experience, which is why we brought this to the ops area working group, we want to get operational experience with this stuff, we'll examine and challenge every last assumption that we've made in what is about to be a proposed standard. And it's only a proposed standard because we do want to get a lot of operational information as we go forward. So that's about where we are with MUD. Comments, questions? Oh, good. Alan's coming to the mic because I was thinking about you, Alan, when we started thinking about IETF.
Sad news, yes. I spent a lot of time working on TEEP, among other things, at least on the standards layer. Almost no one implements it. I've heard rumors of implementations, but all the people who were very enthusiastic about getting it done and working on the standard are working on other things now. I think
Yeah, I bet.
Polite version, as in they got the standard done, but none of the implementations. Similar things happened to me. I was involved in NIA for a while. It's my frustration with a lot of this work. It's good. It can solve problems, and it sort of languished after the standards phase. I have heard recently there's more interest in TEEP, but I don't really have any advice to offer you than oops and sorry.
Thanks, Alan. You know, so the fundamental issue we know we have a problem with, you know, with these things up there or any particular device that doesn't have a direct user interface and wants to use Wi-Fi, they have to go through some sort of dance to get connected. Whether it's EAP or whether it's something else, I personally think using something like EAP is a useful mechanism because it's there in a tremendous number of deployments already. EAP-TEEP isn't. We're not wedded, at this point, I'm not wedded, nor are any of the co-authors who wrote the draft I referenced, wedded to any particular mechanism. We are, however, wedded to solving the problem. And so we're looking for collaborators on that point. And so if you haven't read that draft, please take a few moments and read Owen Field's draft on this. Owen is around. I don't think I see him in the room. Oh, there he is. Okay. And so Owen's got a problem. He can talk about it. He does collaboration devices at Cisco. So he's hitting this problem today. Needs a solution today because it's stopping us from selling stuff. So there's money to be made, as it were. Okay. Any other questions? All right. Thank you for your time.
Thanks a lot.
Next, IPFix PGP community.
The next set of slides will keep up in one go.
Did you want to run the slides or?
You can raise your hand.
Sorry, I might close the window so it's going to be essentially okay. Find it. So we have that.
Yep, that's the one. Yep.
PowerPoint. Yay. Full screen. Thank you.
Hello, everyone. I'm Zhen Qiangli from China Mobile. Today, I'd like to report the current status of this draft, export BGP community information in IPFix. This document passed the working group last call a few weeks ago. Many thanks to all comments and suggestions from the experts, operators, and the early review of the related working groups. We have solved all the comments and suggestions in this version. Here are the significant comments. The first one is about the purpose of this document. We all know that IPFix is the protocol used to collect the traffic flow information from the exporters running the routers. Based on the field network practice to analyze the traffic, to do traffic engineering, or to deployment the quality of services, we want to know the network traffic generated from or destined to some kinds of customers, services, or the geographical regions. Based on the network operator's planning, BGP community attributes are used to represent those kinds of information. So we know the information we want. We can analyze the traffic, the network traffic in BGP community granularity. However, at present, there's no BGP community information can be exported in IPFix. So we introduces some information elements in this document to meet the gap. The BGP community information related to a specific flow can be exported together with other flow information in IPFix. Please read the new introduction part for the detailed explanation and section 3 for the use case. We don't want to, we do not define any new BGP community attribute in this document. The information elements introduced in this document are used to export the already defined BGP communities, such as the standard BGP community, the extended community, and the large community. And this document is not used to replace the BGP monitoring protocol either. For the IPFix collectors are not running BGP and BMP protocols. By supporting the information elements introduced in this document, they can analyze the network traffic in BGP community granularity directly. Because both BGP and BMP are very heavy. Running those kinds of protocols and correlating the traffic flow information with the BGP information are not trivial for the IPFix collectors. The second comment is about the processing of the exporter. We added some text in this version. When the IPFix exporter receives the IPFix template containing the introduced information elements, requesting to report the BGP community information, it obtains the corresponding BGP community information by correlating the traffic flow information with the BGP information. And then the exporter encodes it in the relevant information elements and report it together with other flow information to the IPFix collectors. For the third comment, it is about the processing of the collector. When the collector receives this side, it obtains the BGP community information encoded in the introduced information elements. The IPF collector should ignore the information elements when their sizes are not correct. And then the collector accumulates the traffic at the BGP community granularity and reports results, or does the traffic engineering based on the results. For the next steps, first comments are appreciated, especially the comments from the operation community. And I hope you all are happy with this version, and the working group may consider to move it forward to be published. That's all. Thank you.
Benoit Clay. So I haven't read the document in the last call because for me it was so obvious that it was something to be done, specifically because it's an IPFix structure information element. You could have gone to IANA and requested directly. It was better to document it on how to use these information elements. Okay, this is good. Now, when I just checked it now, there is one small mistake in there. You say that you update the RFC 7012, which is the information list of information elements in IPFix. Actually, you don't. You don't need to update that RFC. You're just using the IANA procedure in that RFC. So the update in the header of your draft doesn't need to have, you want to remove it. You don't need update 7012. Does that make sense?
Okay, thank you. I will do it. Okay, thank you all.
Thank you. How many people have read the latest BGP community draft? Show of hands. 1, 2, 3, 4. Okay, thank you. 4 people in the room. We would appreciate more eyes, clearly, to spot some things like that. Thank you, Benoit, for noticing. Please read, please review, and comment on the list. Oh, and Benoit's going to say something else.
One quick question. I see the version which is now from March 5th. Is this the one? Is it the latest one, or are we expecting a new one? It's the latest version now, or we're expecting a new one? All right. The answer is that it will be updated soon, so I'll review that one.
Okay. Did you want to? Yes.
Good afternoon, everyone. In the next 10 or 15 minutes or so, I will talk about our initiative on building a framework for network telemetry. Telemetry has become a very popular mainstream term in network community, but people may have a very different idea on what telemetry is and how it's related to IETF and how it's used in actually network to help network operation. So from the Greek roots of this word, telemetry simply means remote measurement. So in this sense, we believe telemetry is actually about network visibility. So any technology that help network to gain better visibility by collecting data from network and do an analysis and measurement on it is actually qualified as a telemetry. So in this sense, all the OEM techniques or protocols published in the IETF is actually can be considered telemetry. But as the network is evolving, and we also see the new network requires provide a lot of new requirements to telemetry, and also asks the new telemetry to bear some new characteristics. Okay. Sorry. Okay. As we see, the network is continue evolving past the SDN, and now it's toward a more automatic, intent-driven network. So such network has aimed to reduce human labor and improve network agility and the performance. Also help to optimize the network resource utilization. So you can see in this network architecture, network visibility become more and more important. After all, if you don't know what's happening in network in real time, no effective network control and operations can be applied. But now, I think people just don't put enough attention to this technology. We believe that the telemetry should be promoted as a first-class citizen in the network technology and the protocols. Also, if we look at the current status of such technologies, we see it's pretty much fragmented. We believe we need to unify and consolidate and integrate the existing solutions and also guide the future work in a unified framework to help such technologies to evolve. Currently, we believe the existing OEM solutions are inefficient and also insufficient to sustain the future intent-driven network architecture. Because technology such as SNMP is still used in network, but it's based on the low-frequent polling technology and also the use in the command line interface. But now we need the technology can directly talk to machine rather than human. And also the old OEM technologies lack of coverage and timeliness and accuracy. Also, these OEM mechanisms are scattered throughout the IETF working groups and are a little bit unorganized. And there are many piecemeal vertical solutions. It's very hard for users to compose them into a complete cohesive solution. And also, since people don't work under the same framework, there are occasionally repetitive and redundant work is happening. And there's also lack of collaboration and consolidation between them. And in many times, OEM is not considered, it's just considered an afterthought, patches to the existing solution. Also, it's a work on case-by-case cases. And there's a lack of a holistic and systematic view. Therefore, we believe a framework is actually needed to normalize concepts, terms, and technology standard to help the technology and standard development within IETF. So what's needed in new telemetry? Since the telemetry will be, data will be consumed by machine more than by human, it means the data quantity is large and it happens in real time. The network need to continuously monitor the network in a more dynamic and interactive way. For example, the application need to keep refining what to look at and also to refocus its monitor point. And also the data will be collected from many different sources, in different locations in the same network nodes, also throughout the network. And the data from multiple sources need to be correlated. And there are already different techniques like the passive and active measurement to the network, but we believe we also need to support the in-band measurement to gain the first-hand experience of network flows. And also, we still can't to look at all the data all the time. And that's why we cannot collect all the raw data. We need to customize what data to collect, which means we need to rely on the network to pre-process some of data as guided by the application. And another important thing to think about is that the telemetry should not interfere with the device main function, which is forwarding packet fast. So for example, you can note by a monitoring network, you reduce forwarding performance. That's acceptable. There are many application existing use cases. The first is about intent, verification or enforcement. The intent engine may apply different policies or have different service layer agreement with users and services. But the telemetry is used to ensure that it actually meets the requirement. Also, the network failures happens all the time. So the network need to use the telemetry technology to find the root cause of the failure quickly. And even better, it need to, based on some existing symptom, to find the, to predict the failure. And so the network can be fixed in advance. Another big group of application is about to optimize the network by monitoring the network status. So some intelligent algorithms can be applied to avoid the congestions and to utilize network bandwidth more efficiently. The last very important application is, of course, the network security. For example, the intrusion detection, prevention, and also some other malicious attacks can be identified through the telemetry technology. So all these applications require some new characteristics. The first noticeable one is the push-based technology will replace the pull-based technology, such as was used in SAMP. And since the data quantity is huge, it requires very efficient data encoding. And also the data need to be sent to the collector in a streaming fashion. For better machine consumption of the data, the model is needed. And also, as I just said, so the data collection need to support also the in-band data. And since a data plane or device are becoming more programmable, now it's feasible to support the custom and on-demand data, which means the controller can define, specify what data need to be collected, and using some programming or configuration ways to download that data request to the data plane and just get exactly what data they want. So this is a new characteristics. And last, the telemetry must support to be better integrated with the big data analytics or other machine learning tools. That's very important. Therefore, we can see based on there are different planes in the network, clearly there is better to partition the telemetry also into three different planes. Namely the data plane telemetry, management plane telemetry, and control plane telemetry, right? But between these different planes, there are also some interactions between them. For example, the management plane telemetry can also collect data from the control plane and the data plane. And in each plane, we can further partition the telemetry into 5 unique components. The first one is the data source. It tells, okay, where the data should be, is available, is accessible. And the second component is a data subscription. It cares about, tell the application, how you can subscribe, what protocol or what interface to use to subscribe data. And the third component is the data generation. It's about how the data, because the application may ask some custom data, or the data need to be pre-processed in data plane or encoded or filtered. All these actions belong to the data generation and the preparation. And another important components is data export, which cares about how you deliver the data to the application who will consume the data. And the last, the top components is data analysis, which is actually the applications who will consume the data extracted from the network device. So based on this partition, we come up with this two-dimensional matrix. And we already map many different technologies in this figure. Most of them are from IETF, existing work. They are either already standards or some recent proposals. But only on the data analytics part, you can see most of them are still open source project or some open source tools. But later there might be also some standard requirement in that area. I don't have time to go through this each piece of technology. If you are interested, you can read our draft to see how and why this fit into this picture. So from this picture, we can see there are already a lot of existing works, but they might come from very different working groups, different area. We think with better, if we can map them clearly, it can also guide us in the future how we will map the new work into this picture. And for the system designer, it also can help them to figure out what's the best suite of technologies they can collect to form a complete solution from this figure. So therefore, I think it's very useful. So finally, just a recap our intention for this draft. We want to promote the significance of telemetry work in IETF. We want to remind us to keep the big picture in mind, because we believe the intent-driven intelligent network is coming, and we need to better prepare for that. It's better to avoid, the separate, standalone, piecemeal solutions. Rather, we should consolidate all the telemetry work and provide the unified interface to such network architecture. And we also want to ensure that to make IETF still the leading standard organization in this area. And in this document, we want to formalize all the telemetry-related terms and clarify the technology classifications in IETF, which can consolidate the existing work and also help us to get the future work. Of course, this is just a very early step. We call for more helps and collaborations from other operators and vendors to finish this work. So that's all. So any questions or comments?
Comments from the room?
I have a comment and a question. The comment is that I get the feeling that you're trying to boil not one ocean, but multiple of them at the same time. The scope of this work is not that it is huge, it's more than huge. But at the same time, you say that majority of the components and the other work areas is already being covered and works at IETF. And to me, what you're describing is much more of the network design, or actually product design question, than the protocol engineering, what is typically done in IETF. And the goal to have a one universal, absolutely universal interface that covers absolutely everything, that's directly contradictory to how the network from operational point of view works. There's a differentiation between different operators for a reason, because they are trying to build the different products, different interconnection products, connectivity products. Therefore, trying to build one really nice, all-encompassing interface might be a nice academic exercise. And I don't mean anything negative by the word academic. But is it really practical? We are clearly talking about multiple years of heavy work in all of this, if we want to cover at least the surface of what is described here in the scope. But is the end result going to be worth that? So For example, what is fundamentally wrong with the current OEM? And yes, IETF spends a lot of time working on different OEM aspects, different protocols, different working groups. Those things are deployed, they work, and there are not that many complaints about specific components here in OEM. So is this really such a big problem that it requires the complete re-engineering of the whole of the network, of the whole of the internet? My impression is that the scope here is let's re-engineer the internet from the beginning because it's broken.
Yeah, I agree. It's very hard. But in the past, for every piece of new protocols or technologies, people come up with their own way to do their OEM, and they solve their particular problem. But here, I'm talking about if in the future we have this intelligent network, automatic network, keep the human out of the control loop, then you need to present. I think it's required to present a uniform interface to the intent engine. It's better to avoid a lot of different incompatible interface protocols to talk to the controller. So that's I think the motivation from this big picture. And we list in the matrix several existing technologies, and we can see actually the key components here is what's needed to communicate with the intent engine is actually just the data subscription and the data export. I think there's a good chance we can come up with one unified solution that everybody will agree with, and then we can support such kind of a network architecture. So also, I don't think that's impossible.
So to come up with one universal global intent engine and one universal global controller to control that intent engine, that's an ambitious goal, I would say. Yeah. I'm not saying that it is wrong goal, but it's ambitious.
Yep.
I'm channeling Laurent from Jabber, and she says about your components of telemetry slide. Specifically, some functions seem not to be addressed, like data transport / distribution, data storage, and their respective optimizations. So if you go to your slide called components of telemetry, yeah. The comment is that some functions seem not to be addressed, data transport / distribution, and their respective optimizations, and data storage. So data transport / distribution, data storage.
And storage. Data transport and data storage.
Storage, yes. And their respective optimization.
And last one?
Respective optimization.
Optimization.
Optimization. Oh. So optimize data transport, if I understand right, it should be covered in the data export. And for the storage, it's actually in the data analytics. Usually you have two ways. Either you directly consume the data in the stream fashion, or the data should be first put into some kind of database for later analysis. So in my understanding, that should be also covered in the data analysis components. And last one about the optimization. I think, optimization can happen everywhere. Particularly in the data generation, okay, that's intent to do some data preparation, and that's a lot of optimization happen there. It's like the data dedupe, filtering, and compression, encoding, and also the algorithm, optimization algorithms can also happen in the data analysis components. So yeah, I think all of this should be covered by this. Maybe we can have a better description of each components. But I think every key components happening in the telemetry system is already covered here.
So Tim Carey, Nokia, I just want to say a couple things. One, I want to reiterate the fact that you're boiling a big ocean here, and it's probably too big to boil for what you're trying to do. The question about the transformation in those elements, yeah, that can be part of the data analysis components, but it's a big component, right? You got enrichment and everything else that you have to go through there. And so to just say, I'm going to have a miracle occur here called data analysis, I think would probably do a disservice to the industry. I did see that as you were going through here that you said, let's keep our eye on the intent framework. And it looks to me as we went through this that you took your eye off the intent framework. So if you take an intent, right, and you realize all these sources, it goes to the one protocol piece. You're going to realize real quick that the intent gets realized in many, many different ways, right? And that many, many different ways are going to have different sources of data that's going to come up to you. And they're going to come up to you a different way. So there's not going to be one protocol that you're going to be able to capture these elements through. So there, you have to expect that you're going to realize that intent in multiple different environments. You've got the 3 different control planes there that are the largest pieces of it. And those elements themselves will be going down and being collected through different protocols and different mechanisms. So that's just going to be a fact of life. The question is how you correlate that back into an intent. I think now that probably has some value, right? In trying to figure out how you would correlate the sources themselves into an intent framework, right? But to say that you want a single protocol going into an intent control engine, I don't think that that's going to be a reality probably before I die.
So it might be too ambitious to try to unify all the technologies. But here the main intention, I believe, is to try to organize the existing work to have a clear understanding of what's the scope of this problem and how we can partition the technology, how we can map the existing technology into this map. If we all agree with that, then later, even we develop new technologies, we know where it's fit and how it's fit into this picture. So
if you take every one of those, and some of those are just plain protocols, they're not even frameworks, right? That you're showing on the open source piece of it. But let's say you take a framework, let's say ONAP or something like that, right? You realize that those frameworks, when they get realized, they are built with the realization that there's going to be sources that are going to come from disparate places, right? And so there's not any framework that's going to say, I'm going to have a single protocol and it's going to be the only thing I'm going to support. You're always going to have something that's going to be able to collect from multiple sources. And in that piece of it, you're going to do the appropriate transformation and enrichment that's necessary to meet your intent framework, right? And so, yeah, I think that I don't think you're ever going to get to the point where you only have one. You only have the IETF ones here. I can go to, any number of other organizations, and they've probably got their other 4 or 5 that they're doing to collect stuff. So I just don't think it's probably something that's ever going to happen in a lifetime. And I think you have to look at how you would then be able to set up an appropriate framework that would be able to map and transform the data that you get from the various realization sources into the intent. And then I think you have a chance if you try to do something like that. But I wouldn't try to do it as a single protocol.
This is Robin from Huawei. I want to add some comments about on the presentation. So first, the draft is not to try to boil the ocean. So this is the first comments. Since, but I think that the intention has been explained through the response from how you, I think, is our purpose. The first, we don't think the existing OEM work in IETF is enough, because every time we introduce some of the new mechanism, At the same time, it will also introduce some shortcomings. I think this is the fact in the actual deployment. So we think that is in here that we mainly that related with some of the telemetry work related with the data plane, some of the new OM mechanism introduced, and we also want to identify what should be cope with. So this is our first purpose. Second one is that is this related telemetry is a new error, is related with the huge data will be collected from the network, and it will support the intent-based network or network intelligence. So that is what is missed and what should be done. So we will set up a clear framework to that guide our work in the to be done in the IETF. So I think that is our major purpose. But I agree this work will related with many work in the IETF. So that is why we present this OPS, AWG, and RTG, WG later in routing area. So that we anyway this is a start point. We is open to the all the possible comments and would like welcome your suggestion.
We'll cut the mic off, no one else up, but I did read the draft, and speaking from the chair, I think you've heard a lot of the comments that the scoping, everything you show here is in flight, it's already out there. I think maybe the suggestion is to listen to the comments that you've heard here, and please do read. If you haven't read this draft, read it, comment on it, and you might have to refine some of the scoping and clarify what you're after, because you say make telemetry a first-class citizen. I think people are waking up to the fact that it's needed, but then you also say correlate or aggregate, or I can't remember the exact word you use. I don't think people here in Opsawg in general have the visibility across everything to do that, and I don't think we should be the one true gatekeeper of telemetry. So focus on the intent, and maybe there's a way to refine or sharpen what you're trying to do with this draft so that it does fit a gap that you perceive, or that's more actually that's real with what else is already going on and work that's already in flight in ops and in other areas.
Thank you.
Thank you. Next up is Chasm. Your weapon?
Hello everyone. My name is Xie Chongfeng of China Telecom. It's my pleasure to give a presentation about Chasm, coordinated address space management. As we all know that address space management is an integral part of any network managed solutions. The network may be based on some legacy ones or some new kind of networks, such as cloud-based network. So here I want to give some two cases. The first one is about operator network, large-scale operator network. So operator need to manage the address space, manage addressing needs of network elements, which is right now many use some datasheet solutions and configure them manually for some large-scale network, which is label-intensive and time-consuming. The second use case is for enterprise users. Some enterprise users may use tools such as IPAM to manage the address resources, often with some proprietary database interface. So there is a need to develop a general architecture for the address space management to many use cases, to meet a wide variety of use cases. So the scope of this draft, in this draft, Chasm is a general and synchronized architecture for automatic address space management. it is intended to be used a wide variety of use cases. Hopefully, it can help to reduce the workload of manual configuration, which is very popular in current network. And also, we hope to improve address resource usage, improve the efficiency in the future. So this draft can also be a basic document for artworks, such as interface modeling and workflow design. The use cases of CASM, which may cover automatic address allocation and release and reallocations based on the actual usage and the input from user intent for some service. So all these cases below has been discussed in IETF 98 in Chicago, such as address configuration for BNG, the virtualized BNGs, IPv6 transition devices, address configuration of APAM, API IPAM, SDN controllers, and interface to RPKI. So since it has been discussed in IETF 98, so I will not detail them again. This figure shows the architecture of the CASM. It is composed of 3 layers, application layer and the coordinator layer and the device layer. And the application is a function entity which maintains, operates the CASM coordinators, issues commands, issues a policy or requirement to the coordinator. So the typical example of application is some such as OSS, BSS, and SDN controllers, and any third-party applications. So with this application, operator or enterprise users can access the address usage information, logs, etc. For the coordinator is synchronized function entity, which many use to maintain the overall address resources and processing requests from lower layer devices. It is composed of 3 components such as address pool management, and address database. So the third layer is a device layer. The device agent in the device will distribute address from which is received from the coordinator configured in the device. The type of device may be various, or maybe virtual or physical. It may be servers or endpoints, such as BNG, virtual BNGs, and firewalls, and some other devices, and so on. So when a device needs IP address pool, it will issue a request to the coordinator. The coordinator will compute and allocate a specific address block to this device. So when an IP address block is not used anymore, it will be released and returned to this to CASM coordinator as well, so to improve address usage. Here we give some general features of CASM. It is designed to be a single solution for wide variety of use cases, such as a network device and a security device, server and endpoints, physical or virtual. Of course, this solution should meet the address, should meet the wide variety of address types, such as private, public IP address, IPv6 address, and multicast IP address. The second, it is synchronized dynamic coordination model. So here, the coordinator can make the decision IP address based on the available IP address resources and the user input, the input from the devices. And then the last one is that it is open and integrated with other management services such as legacy Redis and DHCP server, and some new ones such as OpenStack and SDN networks. Another important features of CASM is that it uses that interface modeling. So standard interface will be defined between the CASM applications and the coordinator. So the technical hidden in the nonlinear network will be, technical detail will be hidden to the operator or users. Interface modeling will be a future work based on the progress of this document. So here we only give some general requirements for the interface, such as functional requirements, general operational requirements, and the interface modeling requirements. Actually, we have implemented the field trial of synchronized address management for more than 1 year. Following the CASM model, we developed a synchronized address management system and deploy it in our product network. 4 vendors joined this field trial, and the equipment include the virtualized BNG and the physical BNGs. So with this system, we can manage, we can coordinate and manage the address centrally and dynamically. So about the next step, and the current document will be further refined based on the comments. And we are also considering to do the interface definition in other new drafts. Any contributions are welcome. And I hope that you guys can join this work if you have interest to this. And so I also want to know whether it can be adopted as a working item.
I've got, before we open it up for comments, you had a BOF a while back. I can't remember the IETF meeting number. 98 in Chicago, okay. And I looked at the mailing list recently and kind of conversation died off there. So I'm curious what's bringing the work forward now? What has changed since the BOF? What have you learned out of that that directly influences this work?
Actually, we have up the draft update based on the comments in the BOF, and with several documents has been merged into one into this architecture draft.
So you think there's no open issues left?
No major open issues. Okay.
So Joe Clark is a contributor. I've read the draft. It does look like 2 drafts that have been fused together. You mix terminology. You reference drafts that have been expired. It was really confusing to read. I'll be honest with you, because you mentioned CASM in the second part of the draft, but in the first part of the draft, you have different either acronyms or you refer to the same text in different ways. So it was a little bit confusing to read. I don't disagree that the problem space is interesting and should be solved, but I think more refinement is needed.
Yes.
To really hone in on what you're trying to propose and then emphasize on what you want to standardize.
Okay.
Okay. I would like to know the interest from the working group. Firstly, how many of you have read this document? Please raise your hand. 4 or 5 or 6. Okay. And then how many of you have interest about this document? Please raise your hand.
I'd like to see a little bit more on it.
Okay. Let's discuss more in the mailing list.
So one comment on this topic. A while ago at NANOC, I had a discussion with enterprise operators, and while the topic was different, but it naturally came about address management. And when I simply told that at some point of time in IETF there was a document trying to address that, there was a big interest from that group. I approached them again asking for a review of your document. You probably haven't received that because I haven't seen anything. But one suggestion, ONUG, Open Network Users Group, is an entity which covers many of especially enterprise users. And enterprise users in the domain of containers, virtualization, and then similar type of things, they do have certain problems with identifier management, not only address management, but identifier management in general, not only IP addresses, but that might be VLAN numbers, might be MAC addresses, might be other things. It might be good to extend the solution to cover these type of use cases. And in fact, that might then start addressing a much broader problem space than you are just looking right now into that.
Okay. Thank you.
So please read and comment on the list. And thank you.
Okay.
I think last up we have virtualization overview. Sorry, the Yang model for virtualization. Yes, and can I just say we're running? I apologize, running a bit short on time. So anything you could give back time-wise would be great. We have 5 minutes left, so.
Okay. Hello. Good afternoon, everyone. My name is Qing Wu. The topic I want to introduce is about the network virtualization overlay resource model. This is actually resource-facing model. So why we propose this draft? Actually, as we know, actually IETF proposed quite a lot of young data model. Most of actually device level model. We also have a few service level model, and many of them make a good progress. Recently get published, and based on L3SM, this actually is FCC 82949. Actually, by mapping the service model into the device level model, we can actually provide a service delivery, fulfill the service creation. But what is missing part is we think actually we cannot actually provide like a service monitoring, service assurance. And when you get a network set up and get a service created, how do you monitor the service? How do you expose the network performance of the network to the management system? So this is the gap we want to fill. So we propose this resource-facing model, and this resource-facing model is translated from the customer-facing model, and they will work together with service model to provide not only service creation but also service provision, service monitoring, assurance, and also we can use this service monitoring information to do the network optimization. So why the service model and the network element model is not enough? Actually, we can say service model is a service abstraction. It's a kind of top-down. It's kind of top-down model. So customer only interested in the service, so they can break down the service into layer 1, layer 2, layer 3, layer 4, 7 security service, and they can do the mix match. And but the customer don't care about how you realize this service, what kind of resource you can use to realize this service. So we have network element model. They actually focus on the resource abstraction. So we can have bottom-up model. Is actually try to abstract the fundamental network technology, for example, layer 1, layer 2, layer 3 technology. And typical one is like topology model and BGP model and some other model. And we already what do we try to do? Actually, we can map a service level model into the network element model, and actually they will use, for example, service model as input and enter into the ultimate control and configuration application. They can generate many configuration parameters. They can go to different network element model, and we can fit them together using some like a scale mount or some other mechanism to assemble all of these models together, and we can populate this model into appropriate network device. But is that all? Is that enough? Actually, I think what is the missing part is how to expose some service topology to the operator itself. In some cases, you need to really want to know how well or how bad the network is operated. So you need to report the network performance or the network state to the operator or to the management system. They can manipulate this kind of network state to do the network optimization. So you can actually form this closed loop life cycle, the service management. So this basic idea. So we think that we have two approaches. The first approach is you can extend like a service model, L3 SM model, but this has already been discussed in L3 SM working group, but we think it adds a lot of complexity since you introduce quite a lot of op state. So the second way, actually, you can actually create another model, separate model. We call the resource phasing model. This resource phasing model is translated and instantiated from the service model, because the service model will tell you how many sites you want to create, what is the location of this site, and what kind of connectivity you want to create in which site, and some SLA requirements associated with connected service. So you can actually, based on this location information and constraint information, and you can select the appropriate like a PE, or we call this ingress device or egress device, and you can create the service topology. Basically, it's a service topology. What you need to do is actually do the service bounding. So we give the idea. What we try to do is first you can establish this service topology. So because you have allocated PE device information and maybe CET information, you can replace the location information in the service model with this selected PE information. So you can create a service topology. And basically, service topology, you really want to know, for example, you have several sites, they located in different geographic locations. So you need to establish you set up the path between these sites. So you need to base on queues requirements. So you should establish the service bounding to bound the service flow with the path. Well, after you do that, you set up the path, set up the tunnel. You can actually monitor the performance of the tunnel. Maybe the tunnel actually is multi-hop, so you need to maybe monitor each hop the performance, and you can put them together. You can aggregate all of these to calculate the end-to-end tunnel performance. And based this tunnel performance, you can actually try to do some optimization. So you can actually provide the closed loop service management. So here they show the like service topology creation, and yeah, we already discussed this, and so we can see the resource model actually just translated from the service model or instantiated from service model. The difference is actually we need to pick the selected P to replace the location information in the service model. So the bounding between the service and path. So you because in resource phasing model, you actually you can keep the same queues parameter aspect from the service model, and you can base this queues requirement to calculate the path for each flow, and you can bind the service flow with the path, and then you can actually monitor the path performance or tunnel performance, and you can report this to the management system, and then you can do the optimization. So for the performance parameter, we can have like a per site network performance parameter. Also, we have some performance parameter associated with multiple sites. We call this end-to-end performance parameter.
So when you use all of these proposed parameter as the network performance criteria to calculate the path basis, the performance parameters. So that's my idea.
Thank you. We're over time, but please, how many people have read this? Quite a few, actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Please comment on the list. Where are the blue sheets floating around? Excellent. So thank you very much for attending Opsawg. We'll comment on the list on this last draft, on all of them, and we will see you next time. Warren wants to say something.
And I want to apologize to the presenters. If I'd known we were using my laptop, I'd have had stuff more organized, but we had AV issues. And also, thank Benoit again.
One more for Benoit. Yeah.
Hey, Joe, I think we need to write an email and bring Helen and
yeah,
and also to that.